Okay, guys, today is Wednesday, May 13th. So top left corner of your paper, 5/13/20. Okay, Wednesday, May 13th. We're in Algebra 2, Mod 8. We're going to continue with our graphing specific types of functions that we outlined our first day. If you look at that outline you created day 1, if you look down to Wednesday here of this week, we did linear functions yesterday. Hopefully that was a pretty simple process through those. So today, of course, the title quadratic makes sense. Quadratic functions are any functions that are y equals, and you end up seeing an x squared of some kind on the other side. Okay? Now again, I've got 4 parts on my paper. You might as well divide up your paper and do one function in each block. And then your homework will be 4 functions that you're going to do and submit to me by tomorrow at noon. Okay, they'll be due Thursday, the 14th by 12 o'clock. Stick with the schedule here, guys. Instead of sitting in class for 48 minutes and then going home and doing homework, you're going to watch a 10, 12, 15-minute video and do a 5-minute assignment. Big deal. Keep up on a daily basis, okay? Hang in there. All we've got is this week and next week, and we're done. All right, number 1. Go ahead and write y equals x squared minus 6x plus 8. Now, your job is to sketch that picture quickly and accurately without touching a calculator. There is not a calculator out on your desk right now. So when you submit this assignment, I should see an XY table or some work that you're showing that kind of follows and mimics the procedure that I'm now reviewing with you. Notice I said reviewing because you've already done these. This is a library of functions you're supposed to carry forward with you that you've been introduced to this year. Now, I think you do know, of course, that an x squared, a quadratic function, is a parabola, a curve, correct? If it's a positive x squared, it'll be a smiley face. If it's a negative x squared, it'll be a frowny face, okay? So what's going to be our procedure for graphing this as accurately as we can? Okay, guys, there's only 3 things you have to do, okay? Step 1. Make a table off to the side, and I always start. Now, you do need some room to show a little bit of work in here, so I'm going to draw my picture right about here to give me some space. Always start by simply plugging in 0 for the letter x. If I took 0 and went and plugged it into that problem, obviously 0 squared is 0. Minus 6 times 0 is still 0. Plus 8 gives me 8. Remember, that's called your y-intercept. I'm about to draw a parabola, and I now know that it crosses the y-axis, right? It's called my y-intercept at 0, 8. So I'm going to go up 8. All right about there, pretty tall, and put a dot on my y-intercept. That is not my vertex, right? That's where my picture touches the y-axis at. Okay, speaking of vertex, that's my second point. Remember I said there's 3 things you do? The first thing is plug 0 in for x to get your y-intercept. The second thing you do, I'm just going to go right under the table and write v equals. Remember, when you draw your parabola, how do you know where the vertex is at? You should remember a formula. Might as well write it down on your notes. Opposite of b over 2a. Oh, that's your vertex formula. So the opposite of b. So you go to do the opposite of the middle number, which is negative 6. So the opposite of negative 6 is 6. 2 times a, well, my first number is a 1, isn't it? So 2 times 1 is 2. So my vertex has an x-coordinate of 3. So 3 is the next number I put on my table for my vertex. And I actually take 3 and I go plug it in for x. 3 squared, okay, is 9. Minus 6 times 3 is what? 18. Plus 8. Add those up. 9 minus 18 is what? Negative 9. Negative 9 plus 8 is -1. So I'm going to go right 3 and down 1 and put a V by my vertex. Okay? And now that I've got that, all right, guys, all you've got to do at this point, since I've got a y-intercept and a vertex, remember there's always what they called a axis of symmetry going right through there, cutting the picture in half now that you know where your vertex is, and you have your y-intercept. The third thing you've got to do is just draw this guy, look where my pen's at on that dot, draw his reflection on the other side. Obviously, this dot is 3 inches away from the dotted line, so his reflection is 3 inches that way. Oh, so now I have a symmetric, well-proportioned picture, and I draw my curve. All right, so a nice, normal, positive x squared. Find your y-intercept, find your vertex, draw your axis of symmetry. That's an imaginary line. Create a reflection point, and you've sketched your picture. I did not touch a calculator, okay? That's the goal here. Now, what if it's a negative x squared instead? Now you're thinking frowny face. Guys, regardless of whether it's a smiley or a frowny, watch this. I'm going to quickly, right? We can scoot through this a little quicker now. Let's do the same 3 steps. Always plug 0 in for x for step 1. What's 0 squared? 0. What's 2 times 0? 0. Plus 3 gives me 3. So I already know my y-intercept is on 0, 3. I got to see that as your first dot. My vertex formula. Again, I'm using -b over 2a. We've already written it over here, so let's just go ahead and calculate it. -b would be the opposite of b. The opposite of +2 is -2. And when I do 2 times a, notice the number in front here is a -1, isn't it? So 2 times -1 is -2. And -2 divided by -2 gives me 1. So that's the next number I put in there. Now, he needs a y-coordinate partner. So go plug 1 in for x. Now, careful, guys. Everybody watch very carefully here. This is where you'll make a mistake if you make one. If I take 1 and go plug it in, it looks like you're taking -1 and squaring it. And when you square a negative, you get a positive. But that's not what we're doing. This is really -1 times and then x squared. So guys, pretend that negative's not there. If I take 1 and I go plug it in, 1 squared is what? 1, but there's a negative in front of the 1 I just created. So -1 plus 2 times 1 is 2 plus 3. -1 plus 2 is what? 1 plus 3 gives me 4. So I'm going to go right 1 and up 4. There's my vertex. I've got an imaginary line going right through there. I take this dot, look where my pen's at, draw his reflection right there, and I've accurately placed my parabola. I'm 2 for 2. Third one. Now, even though it says 2x squared plus 8x, notice it doesn't have a third number, does it? That's okay. I still realize it's a quadratic function, so I'm still going to make a table and plug 0 in for x. 0 squared is what? 0 plus 8 times 0 is still 0. And since there's no number to add on to that, 0, 0 is my y-intercept. So all that tells me, okay, big deal. You'll have one on your assignment just like this, that it touches the y-axis right on the origin at 0, 0. Now remember, that's not my vertex, right? That is not my vertex. That's my y-intercept. To get my vertex, I still can use what formula? -b over 2a, agreed? -b, remember that means opposite of b. What's the opposite of +8? -8. 2a is 2 times 2, which is 4. Negative 8 over 4 gives me negative 2 on your table. When you show me your work, that should be your next number. I'm going to take negative 2 and I'm going to go plug it in for x. Now careful, remember I'm not using a calculator, I'm using my brain. Cover up the number in front. I'm taking negative 2, look, and I'm squaring it. When you square a negative, you get a positive 4. Times 2 is 8. Plus, and then what's 8 times negative 2? That's negative 16. So 8 plus negative 16 is negative 8. So I'm actually going to go, hopefully you got enough room here to go down 8. Right there for me. So I'm going to go left 2, down 8. Put a V for vertex. Draw your imaginary line. All right. Now, guys, that dot is 2 inches away from the imaginary line, so his reflection is 2 inches on. This is not difficult. And now a nice curved shape. We knew it was going to be what? A smiley face, right? Because it was a positive x squared. All right, last one. Oh, boy. Again, probably going to see that next year and say, oh, my God, I don't remember how to graph that. Well, that's the reason we're doing this. You're supposed to remember this. Your brain has got to think, what? That's a quadratic function. It's negative, so I'm drawing a parabola that's upside down. To accurately draw it and put it in the right spot, I'm going to make a table, plug 0 in for all the x's. Well, 0 minus 0 plus 6 gives me 6. So I know, don't say my vertex, say my y-intercept is at 0, 6. To get my vertex, I'm going to do the opposite of b. So it'd be the opposite of negative 1, which is 1. Over 2a. 2 times negative 2 is negative 4. So, oh no, scary thought here. We've got a fraction. Obviously a positive over a negative. Negative 1/4 is the x-coordinate of my vertex. Now don't panic. Stay with me. You ready? Last thing we've got to do. You can do it. Take negative 1/4 and go plug it in here. Okay, I'm going to ignore the number in front for a second. You've got to square negative 1/4. Now, don't panic. Doesn't that mean negative 1/4 times another negative 1/4? What's negative 1/4 times another negative 1/4? That would be positive 1/16. Think about it. 1/4 times 1/4 is 1/16. But there's a negative 2 in front of that, right? I'm chicken scratching here. So if I take 1/16 and I times it by negative 2, obviously negative 2 times 1 gives me negative 2/16, which reduces to negative 1/8. Don't be a crybaby. You're in junior in high school. You can multiply negative 2 times 1/16 and get negative 2/16, which is negative 1/8. Now notice it says minus, and then plug in your negative 1/4. So minus a negative becomes plus 1/4 plus 6. Now again, don't panic. I'm adding 2 fractions, so I need a common denominator. Do you agree that 1/4 is really 2/8, right? I wanted to get a common denominator there. Negative 1/8 plus 2/8 gives us what? 1/8 plus 6. Oh my gosh, I did it. 6 1/8. So I'm actually going to plot the point negative 1/4 and go up 6 1/8, just a smidgen taller than that other dot. That's my vertex. There's my dotted line. His reflection is just a smidgen to the left. Oh, and you got a cute little frowny face looking like that. So big deal. Try to calculate your fractions correctly if that ends up happening. Okay? All right. You are now experts on linears and quadratics. You're gonna try these 4. So here's where you'd hit pause on your video, copy all 4 questions down. It again mimics the 4 I just did. Follow the same steps, show the same amount of work, sketch an accurate parabola or quadratic when you're done. Again, today is what? Wednesday the 13th. So this is due Thursday the 14th at noon, not Saturday night at 8 o'clock. Anything that's late is half credit. We're done playing games, and you're not taking a picture of your friend's paper or having them send you a picture of their assignment and you just copy it onto your paper. That's cheating. That's not learning. Please do your own work. You need to give this a shot and make sure you understand how to do them. If you miss a point or two, big deal. Don't be lazy. Get the job done. This is due tomorrow by noon. Sketch all 4 of those quadratic functions, okay? Good job. We'll see you then.